Hey everybody, this is my video on circles and how to work with them so that you don't have to just memorize formulas. If you conceptualize what you see, it's a lot easier to not get confused and to make careless mistakes when you are trying to apply what you've learned and trying to calculate certain things for circles. Before we get started, let's go over some vocabulary that you need to know in order to work with these. So the center, of course, is the middle of the circle. The diameter goes from one side of the circle through the other to the other, but it must go through the center. The radius starts at the center and goes to the outside of that circle. Its relationship with the diameter is that it is half of it. So the diameter goes all the way across, and the radius is half that length, and it begins at the center and goes out to the edge. Think of like a tire on a car, and where the tire goes to the car itself, that's the middle. The radius of the tire would start there and go out to the end of the tire itself. When calculating certain things for circles, the space inside of the space inside of a circle is called the area, just like it is for any other two-dimensional shape. The perimeter of that circle, however, is called the circumference. It means the same thing, but it does have a different vocabulary term. So the inside of it is the area, and the outside of it is the circumference. Now let's look at the concept of pi and why we use pi, what pi actually means, and hopefully getting this in your mind so that you do not make any sorts of careless mistakes in working with this. Let's look at what pi actually means. Pi is the ratio between a circle's diameter and its circumference. It is always constant. Pi, the value of pi does not change. It always is the same, which is why we use it when calculating things for math. Let's look at the next example. Below you have 3 circles that are drawn, each with different radius measurements. The smallest one over here is 2. The one in the middle, or a little left of middle, is 4. And the the largest circle here has a radius of 6.4. Mathematicians a long time ago figured out that no matter what the circle of the radius is, the distance around that circle is usually 3.14 times larger, or 3 and 1400ths times larger. So no matter what the radius happens to be, no matter how much you shrink it or how much you enlarge it, the circumference is a little over 3 times larger than what the radius is. That is why we have the concept of pi. We call this, again, the ratio of what pi is. So when you're trying to calculate certain things for a circle, we're going to start with area. The way that we calculate area is the value of pi times the radius squared. And it is written like this, pi r squared. That's what we refer to that to. When calculating the circumference of a circle, it is pi times diameter. There's no square in it. So it's just pi times diameter. Your parents were taught, probably if you ask them if they remember, that it was 2 pi r, but 2 radiuses equal the diameter. So these two formulas are actually equivalent to each other. I teach it this way so that you don't get the radius confused with squaring the radius when you're trying to calculate the area. It's one of the ways that I try and make it a little bit easier for you so that you don't make any careless mistakes. Now, here's a real life application of what we're going to do and what you're going to be working on. So what you have here is the 3-point arc of a basketball court. These are official dimensions for a middle school and high school size court. So from the basketball hoop out to the 3-point line is 19 feet 9 inches, and the radius of the circle where the free throw line is 6 feet. That goes into the lane, and it also connects up here at the top of the 3-point arc. So this 6 feet is included in the 19 feet 9 inches length. So what we're going to do here is I want you to calculate the area that's been shaded in blue and the area that's been shaded in green. Let's say that they need to paint the basketball court, and you're trying to calculate how much paint or what the square footage is of what it is that you need to paint so that you would know how much you need to buy. So we've got the blue section up top, and we have the green section minus that half arc that's in there. I want you to pay attention to the distance here. From the basketball hoop to the edge of the 3-point line is 19 feet 9 inches, but the length of the free throw area or the lane is a little bit longer to accommodate the little bit of distance between the basketball hoop and the back of the court dimension. So that length is 15 feet 4 inches, but to keep all of our units the same, I wrote that as a fraction. So 15 feet 4 inches converts to 15 1/3 feet because 12 inches are in a foot, and I used it as a fraction. So let's calculate the area of the blue section. If the radius of that circle is 6 feet, I would multiply pi times 6 squared, and I would get about 113 1/10 feet squared. I'm rounding all of my answers to the tenths place for simplicity. One more thing I wanted to show you is the symbol. That didn't come out very good. Let me show you that symbol here. What I'm doing there is this mathematical symbol means approximately. When you're working with circles, you never get a perfect answer. You always get an approximate answer. We can get really, really, really close, but we can't get it perfect. So that's what this symbol means, and it's a more accurate way of answering the question as compared to using the equal sign. Now let's go back. We calculated the area of the circle as 113 1/10 square feet, but you only need half of that. So then we divide that by 2, and we get about 56 6/10 feet. To calculate the green section, is a simple rectangle. So we need to multiply 15 1/3 feet times 12, which gives us 184. But we need to then subtract out the white section of that half circle. So we use the number we've already found, which was 56 6/10, and now we're going to subtract 56 6/10 from 184, and we get approximately 127 4/10 feet squared. So here's the challenge for you. I want you to calculate what is in orange. Pause this video, see what you come up with, and then hit play and get the right answer. So, to calculate this answer, what you would need to do is find the area of this half circle. To do that, you find the area of a circle and divide it in half. In order to calculate the radius of the 3-point arc, we're going to add the length of the lane, which was 15 1/3 feet, plus 6 feet, which was the top part of the free throw area, and that gave us a length of 21 1/3 square feet. 21 1/3 feet. That's the radius of this half circle. Then we multiply pi times 21 1/3 feet squared, and we get approximately 1,429 8/10 square feet. But it's a half arc, so we divide that by 2, and we get 714 9/10 square feet. But now we need to subtract out the green section as well as the blue section. We already have calculated what the blue section was. That was 55.6 square feet. We also calculated the area of the green section, which was 184. Now, I didn't subtract out this white part. I don't need to, because I'm only calculating what is orange. If that part were orange, it'd be different, but I don't have to worry about that. So that gives me 714 9/10 minus 55 and 6/10 minus 184, and my final area is 475 and 3/10 square feet. That is the area in orange of the 3-point arc minus what's in the lane and minus what's in the free throw area.